Hey, this is Mr. Trammell, and in this video I just wanted to show you how we're going to work through all the questions that were on our practice today, just in case you're trying to study for the formative assessment tomorrow that we're going to do in class and you wanted a little extra practice. So for the first one here, I noticed that the coefficients are in the front, so we can actually multiply these the same as we would normally. So 4 times 3 is 12. Then we have two things with the same base, where multiplication is taking place between those, so we can actually add the exponents here off to the side. So we get that this is 12a to the 6th power. Okay, when we take a look at number 2, we have a property that allows this exponent to go into both the numerator and the denominator. So for this example, we can write this as a to the 3rd over b to the negative 2nd power to the 3rd power. All that I've done is that I have rewritten the numerator and the denominator both with the power of 3 this time. I see that this one down here on the bottom has a power to a power, which means that as we rewrite it again, we can multiply those two exponents. So this, instead of being negative b to the negative 2 to the positive 3rd, this is b to the negative 6th. Right? Remember, we can multiply those. Okay, and our last step here to get this in its simplest form would be to rewrite this getting rid of the negative exponent. So we can multiply this or flip this and find its reciprocal, and when we find its reciprocal, the a to the 3rd power is going to stay the same, but the b is going to become positive 6 because it's now technically in the numerator. Right? So we can leave this as a to the 3rd and b to the 6th, or times b to the 6th, and that's our answer. The last one down here, if we want to take a look at this one and rewrite this one, we can rewrite this as x to the 4/3 power, where our denominator comes from the degree of the radical, and our numerator comes from the exponent. So 4/3, x to the 4/3 power times x to the 2/3 power. When we multiply these, they do have the same base, multiplication's taking place, so we can add those exponents. So this is x to the 4/3 plus 2/3, which you all know is going to be x to the 6/3, or x squared. Okay, now we want to determine what the value of x is. That's going to make each statement true. The first thing I'm going to do is I'm going to rewrite this radical expression on the right side. So a to the 4/3 power times a to the x power equals a to the 5/3 power. Now that I see that, I know that I'm multiplying things that have the same base, and the exponents I'm going to add. And so as we do this, we ask ourselves, well, a to the 4/3 plus x equals a to the 5/3. So what number could we multiply in place of that x, or put in place of that x, so that when we add that to 4/3 we get 5/3, and hopefully you see that we can add 1/3 to get 5/3. Okay, so for number 5, we have a to the 0 power over a to the negative x power. Anything to the 0 power here in the top is going to be equal to 1. Remember, this is a property that we have where our exponent is 0. The answer to that is 1. So this is 1 over a to the negative x power equals a to the 4th power. And so now we can ask ourselves, well, what could we substitute in for x that we can get 4, a to the 4th power out? And remember, we can rewrite a negative exponent by pushing it across the fraction bar, or by finding its reciprocal, and we get a to the x power equals a to the 4th power. And obviously the only thing here that can make this true is when x equals 4. Okay, for this one, number 6, there should be an a right here, so this should read a to the x power to the 4th power equals a to the 20th power. So I just wanted to make sure that you knew that that was supposed to be in there. This time, because we have a power to a power, right, we know that we're going to multiply. So a to the 4 times x equals a to the 20th. So 4 times what number is going to get us to 20, and hopefully you know that that number that we can get to multiply that is 5. Alright, so for numbers 7 through 10, we want to take a look at these expressions here, and we want to see which ones, if any, are equal to x to the 3/8 power. right? And we're just going to write yes or no in these blanks. This first one here, I'm going to keep everything that is in the underneath the radical. I'm going to keep everything that's underneath the radical together. I'm going to do that with parentheses. So I know that I can rewrite this as what was underneath the radical, so x to the 3/4 power. But instead of a radical there, I'm going to write it as a rational exponent, which means I know that I can raise this to the 1/2 power, right? Our denominator comes from our degree, and that means that this number here on the outside of the parentheses as our exponent would be 1. So we still get that this is x to the 3/4 power raised to the 1/2 power. Here I see that this is a power to a power, so I know that we're going to multiply those. So I have x to the 3/4 power times 1/2 power. And in doing so, right, we multiply straight across, and we get that this is x to the 3/8 power. Okay, number 8, right, number 8, we're going to be able to rewrite the both of these. So we can write the first one as x to the 1/4 power times x to the 1/8 power. Right, well, when we have multiplication that's taking place between two things that have the same base, we know that we can add their exponents. So this is x to the 1/4 plus 1/8. And we know that we can add these, but first they have to be a common denominator. And so for us to do that, we're actually going to multiply the first fraction there by 2/2. Right? That doesn't change the problem, but it does allow us to write that so they both have a denominator of 8. So here we have x to the, when we multiply this by 2/2, we have 2/8, 2/8, plus 1/8, and we do get that this is equal to x to the 3/8 as well. Right? So this one works. Okay, similarly for number 9, what we can do is that we can write this as a ratio, being a fraction, of two of our x values, both of those raised to a fractional exponent. So this is to the 10/3 power, and this is to the 2/3 power. Okay, so opposite of multiplication, right? When that property is in place, this is the quotient property, meaning that if we have division of items with the same base, and it is division instead of multiplication, then we can subtract the exponents. So this is equivalent to x to the 10/3 minus 2/3, which we know is equal to x to the 8/3 power. Right? Even though that it has both the 8 and the 3 in fraction form, we were looking for x to the 3/8 power, not x to the 8/3 power, and so unfortunately that one's not going to work for us. Okay, down to the last one here, we're going to rewrite what's inside the parentheses first, right? And I can write that as parentheses x to the 8/3 power, raised to the 0 power still, all over x to the negative 3/8 power. Okay, well, I know that based on the power of a power rule, I know that my numerator here, I'm going to actually multiply those two exponents. So up top we still have x to the 0 power, and on the bottom we haven't done anything to that just yet, so we have x to the negative 3/8 power. Okay, we know that when a number is raised to the 0 power, it is equivalent to 1. So we have 1 over x to the negative 3/8 power. And our last step here would actually be to rewrite this with a positive exponent. So to get a positive exponent, we find its reciprocal, meaning we kind of flip the way the fraction is written. So instead of the x to the negative 3/8 being on the bottom, the positive, or x to the positive 3/8 is going to be up top. And really that's over 1, but we know that we can just write this as x to the 3/8 power. Okay, and because of that, that is equivalent to what we were looking for, so the answer to this one is yes. So we have yes, yes, no, yes. I hope this helps.